In the last lecture, we saw how nonlinear models are solved using the Newton Raphson iterations. However, certain highly nonlinear models cannot be solved using the Newton Raphson iterations alone. Consider a load deformation behavior of a structure shown in the graph. Deformations are on the x-axis, while the load is on the y-axis. The force deformation behavior is highly nonlinear, represented by the curve shown. If we try to solve this model using Newton Raphson iterations, we get into problems. In the first iteration, we calculate the stiffness of the undeformed structure, K1, and apply the load F applied on it. As you can see, it may not be possible to solve the FE model, as the deformations are likely to be unrealistically large. Even if we could solve the model for the first iteration, obtaining a complete solution may take a prohibitively large number of iterations. We saw in the last slide that in case of a highly nonlinear structure, Newton Raphson iterations may not solve the problem. Now, we are going to see how we can overcome this limitation. The limitation of the Newton Raphson iterative method can be overcome by load increments. In this method, the total load on the structure is applied in a finite number of load increments. We represent this method graphically. Let us consider the same load deformation curve of a highly nonlinear structure. Let F applied be the applied load, and delta actual be the actual deformations in the structure. Now, instead of applying the entire load F applied in one step, we apply a small fraction of it, F1. We use the same Newton Raphson iterative method to solve the model with force F1 applied on it. As you can see in the figure, it is possible to solve the model within few iterations. As we find the actual deformations in the structure, delta 1 actual, corresponding to the load F1, we go for the next step. In the next step, we calculate the stiffness of the deformed structure with deformations equal to delta 1 actual, and apply additional small load F2. We repeat the Newton Raphson iterative procedure for load F2 to get the deformations delta 2 actual. As you can see, by applying the load in small increments and solving the model using Newton Raphson iterations at each load increment, we can solve the entire problem in 3 to 4 load increments. Each of these load increments is known as a substep.